Humanity is on the verge of returning to the moon this decade, with Starship set to play a pivotal role in this historic mission. In tandem with Starship, NASA is developing additional systems to support this significant endeavor. However, not all of these systems are proving to be effective, with the Lunar Gateway standing out as a point of concern. The Lunar Gateway initiative is currently encountering several challenges, most notably its potential conflict with Starship HLS. What are the specific issues with the Lunar Gateway, and should NASA reconsider this complex initiative? Let's explore these questions in today's episode of Great SpaceX. According to NASA's current roadmap, Artemis 2 is scheduled for September next year, followed by Artemis 3 and 4 missions in September of 2026 and September of 2028, respectively, with both lunar landings being facilitated by SpaceX's Starship HLS, or Human Landing System. Among these, Artemis 3 is particularly significant as it will mark humanity's return to the moon after more than half a century. However, the subsequent missions, especially Artemis 4, the second mission to land humans on the moon, also hold great promise, featuring several major advancements compared to Artemis 3. In addition to Starship HLS, NASA has proposed the development of a system called the Lunar Gateway. This project envisions a space station operating in lunar orbit, serving as a staging point before the lunar lander transports astronauts to the moon's surface. The Lunar Gateway is intended to support long-term, sustainable lunar exploration and may lay the groundwork for establishing permanent bases and extended operations on the moon. However, the situation is not as promising as it appears. The complexity and incompatibility of the Lunar Gateway with Starship HLS have raised significant concerns. A recent report from the U.S. Government Accountability Office, or GAO, highlighted several issues with NASA's plans, underscoring the challenges facing the Lunar Gateway project. The first major issue with the Lunar Gateway is its schedule. Initially planned for 2022, the project has faced significant delays, with key modules like HALO, IHAB, and other subsystems still in development. According to the GAO report, the first launch of the system has been pushed back to at least December of 2027. This delay poses a significant compatibility issue with SpaceX's Starship HLS. While Artemis 3 will not utilize the Gateway, Artemis 4 is scheduled for September of 2028, only about 10 months after the earliest possible launch date for the Gateway. This timeline is insufficient to ensure the Gateway is fully operational and ready to support the Artemis mission. Critical components, such as the HALO module and the Power and Propulsion Element, or PPE, need to be launched at least 12 months before Artemis 4 to be fully functional. Another concern highlighted in the GAO report is the cost of the Lunar Gateway project. The estimated cost until December of 2027 stands at a staggering $5.3 billion US. NASA has already spent significant amounts, $1 billion on the PPE module and $1.3 billion on the HALO module. This financial burden places immense pressure on NASA, with no guarantees that the project will remain within budget or operate efficiently once completed. Now, let's dive into the complexity of the Lunar Gateway project, which unfolds in 8 intricate steps. Step 1. NASA will begin by using SpaceX's Falcon Heavy to launch the Power and Propulsion Element and the Habitation and Logistics Outpost. These two modules will be connected in space and then deployed. Together, they will transit to a near rectilinear HALO orbit, establishing the basic structure of the Gateway. Step 2. SpaceX will follow up by launching its logistics vehicle, the Dragon XL. This vehicle is an upgraded version of the current Dragon, featuring a larger size and increased thrust. The Dragon XL will transit to NRHO and dock with the Gateway, providing essential supplies and equipment. Step 3. SpaceX will then launch a depot into low Earth orbit, or LEO. Several Starship tankers will be launched to deliver fuel to this depot. Once the depot has accumulated enough fuel, the Starship Human Landing System will be launched and docked at the depot to transfer fuel. After being fully fueled, the Starship HLS will separate from the depot, transit to NRHO, and rendezvous with the Gateway. Step 4. NASA will launch the Orion spacecraft carrying 4 astronauts and the International Habitat Module, or IHAB, aboard their SLS-1B rocket. This launch will utilize the Mobile Launcher 2 system and marks a critical step in the assembly of the Gateway and the Artemis mission. These steps underscore the immense complexity and coordination required for the Lunar Gateway project, highlighting the challenges NASA and SpaceX face in making this ambitious plan a reality. Step 5. During the journey to the moon, Orion will separate from the SLS upper stage and dock with the IHAB module, which remains connected to the rocket's upper stage. After docking, the IHAB will detach from the upper stage, and Orion will then tow the IHAB to the near rectilinear halo orbit. Step 6. Upon reaching the NRHO, Orion will dock the IHAB into the gateway. The crew will enter the gateway and activate the IHAB module, where Orion will remain docked for the next 17 days. Step 7. 2 of the 4 astronauts will board the Starship HLS, which will then undock from the gateway, descend to the lunar surface, and land. The astronauts will conduct various activities, including moonwalks, to collect scientific samples over a period of about 6 days. After completing their mission, Starship HLS will ascend back to the NRHO and dock with the gateway. And finally, Step 8. The crew will transfer the collected science samples to Orion for return to Earth. After securing the samples, the crew will board Orion and begin their journey back home. This lunar mission, involving the Lunar Gateway, illustrates a highly complex process with multiple stages and the involvement of various contractors. Each step introduces potential points of failure, as the success of the mission is contingent upon the flawless execution of each contractor's role. For example, the launch of Orion and the IHAB module will be the inaugural mission for the SLS-1B rocket, adding another layer of uncertainty. In this intricate process, reliance on SpaceX systems such as Falcon Heavy and, to some extent, the Starship is key, as these systems have demonstrated significant progress and reliability. As we've highlighted, these processes will take an extended period to complete, leading to exorbitant costs. To put it into perspective, consider the massive expenses associated with NASA's SLS program before the Artemis 1 mission. NASA is under significant pressure due to decreasing budgets in recent years, a trend that may continue. This financial strain has forced the agency to cut costs on numerous projects, with some even facing cancellation. Given this situation, is maintaining the Lunar Gateway truly the right choice? Moreover, the Lunar Gateway system also complicates the moon mission, especially with the involvement of Starship HLS. Before diving deeper into this, please like, share, and subscribe to our channel. Your support motivates us to keep bringing you updates on SpaceX's developments. Now, let's compare the sizes. The power and propulsion element and the habitation and logistics outpost are designed to fit within Falcon Heavy's fairing payload, meaning they are less than 13 meters long and less than 5.2 meters in diameter. When combined with the IHAB and other systems, the overall size won't increase significantly. In contrast, Starship HLS is vastly larger, 50 meters long, 9 meters in diameter, with a dry mass of about 100 tons. This mass will increase once Starship HLS is fueled for its lunar landing. The disparity in size and complexity between the Lunar Gateway modules and Starship HLS presents significant challenges, both technically and logistically, for the mission. The Starship HLS being larger and heavier than the Lunar Gateway could significantly alter the Gateway's orbit when docked. Attribute this to the size of Starship HLS and its propulsion system, but it's important to note that NASA selected Starship HLS specifically for its lunar missions. The responsibility lies with NASA, not SpaceX. Debates have emerged about whether NASA should eliminate one of these systems, with some suggesting the removal of Starship HLS. However, this would require NASA to completely overhaul its mission plans. Starship HLS is essential for Artemis 3, which is scheduled before the Lunar Gateway's deployment. Removing Starship HLS would jeopardize not only Artemis 4, but also Artemis 3. Without the HLS, NASA would face significant challenges in finding a reliable and cost-effective alternative, as other options like the SLS project, Blue Origin, or ULA do not currently offer the same capabilities as SpaceX. NASA may need to simplify its approach by potentially canceling the Lunar Gateway. Building and using the Gateway for the second moon landing seems overly ambitious. Instead, NASA could focus on Starship HLS, allowing SpaceX to develop launch and refueling systems that are more straightforward and cost-effective. This approach could expedite lunar landings and enable future base construction on the moon without the complexities and high costs associated with the Lunar Gateway. As we approach the second half of 2024, NASA must make a decision soon. especially with China advancing its own lunar plans. Simplicity and efficiency will be crucial for success. Should NASA consider abandoning the Lunar Gateway? Share your thoughts in the comments section down below. We're all aware that Artemis 2 is scheduled for launch in September of 2025 and hardware preparations are ramping up. That said, recently after a long production period, the core stage of this rocket, known as Pegasus, was transported from the production facility to the Kennedy Space Center. On July 24th, it was unloaded from the barge and moved into the Vehicle Assembly Building, or VAB for short. This prototype is equipped with all 4 RS-25 engines. Other components, including the solid boosters and second stage, are expected to be delivered and assembled soon. Meanwhile, its launch system, known as the Mobile Launcher, is being taken to add other systems, such as crew access arms, engine sound suppression, and other support systems serving the rocket launch process. With these updates, it seems likely that assembly will take place this year, with tests on the complete prototype scheduled for next year before the launch. However, this is NASA, and it's hard to predict if they will still stay on schedule. With just over a year left until the September 2025 launch target, they must complete the prototype assembly soon. This progress is a rare piece of positive news from NASA lately. Even when everything appears ready, there are still many concerns surrounding the SLS. That's because right now we see that Starliner has launched but cannot return due to numerous issues. Initially planned for about a week on the ISS, it's been nearly 2 months and this mission still hasn't concluded. Although NASA and Boeing remain confident that everything is on track, we all know their current problems are quite complicated. So how does Boeing's problem relate to the SLS? Let's not forget that the SLS core stage we just mentioned is manufactured by Boeing. This raises significant doubts about whether in a more complex mission involving the moon, similar risks might arise. The Artemis 2 mission will carry astronauts around the moon, with the core stage accompanying the spacecraft for most of the initial journey. Its impact shouldn't be underestimated. If problems arise while it's operational, the spacecraft deployment could fail. This could resemble the Astrobotic mission earlier this year, where launch issues caused problems with the Peregrine lunar lander. Unlike the Starliner situation, where astronauts have a place to wait for rescue if something goes wrong, a lunar mission is far more dangerous. Finding a safe haven is challenging and no other vehicles can promptly rescue them. While I don't believe these risks will necessarily materialize, and I hope they don't, my current lack of confidence lies with Boeing's capabilities, and I find that disturbing. But hey, that's only part of the problem with the SLS. Currently, the rocket faces another significant risk: cancellation due to its enormous costs. You might be wondering how such an important project could be canceled. Recent issues indicate this is entirely possible, as NASA has canceled many crucial projects for similar reasons. Most recently, the Chandra telescope, a symbol of space exploration, is dangerously close to its end. Specifically, a NASA committee concluded there is no way to continue operating the Chandra X-ray Observatory at the reduced funding level proposed in NASA's 2025 budget. With NASA's budget set to decrease in the coming years and many expensive projects on the horizon, cost-cutting measures are inevitable. Currently, Chandra's operating cost is $68.3 million, but it will be reduced to $41.1 million next year and further slashed in subsequent years. By 2029, its operating budget might be reduced to just a mere $5.2 million. With such reduced funding, continuing Chandra's operations will be extremely challenging. Therefore, 4 options have been proposed, with the complete cancellation of the project being considered the most appropriate solution. Other options involve cutting costs by reducing operating time or eliminating certain Chandra modes and instruments. However, these are not feasible, as NASA would still incur costs without receiving satisfactory results in return. Previously, another significant lunar project was canceled: the Viper lunar rover. Scheduled to launch on the Griffin mission later this year by Falcon Heavy, Viper's costs had already reached $450 million. Projections indicated this could rise to $609.5 million by 2025 if not canceled. largely due to delays with $322 million lander Griffin, which likely cannot launch before September of 2025. By canceling the project, NASA expects to save $84 million. Both of these issues stem from NASA's ineffective operations. In the case of the Chandra telescope, the cost shortfall arises from NASA's stubbornness with other projects, such as Hubble. Despite numerous problems, individuals like Isaacman, supported by SpaceX, offered to rescue Hubble at no cost to NASA. However, NASA declined and chose to continue operating the telescope for about another decade, despite its problems, inefficiencies, and high costs. As for Viper, after enduring multiple delays over the years and nearing readiness, it was cancelled for reasons that seem unjustifiable. The main issue was, of course, rising costs and future budget overruns. Viper was meant to explore the moon's south pole for water and other resources, which are crucial for future lunar missions. Though it has been officially cancelled, there is still hope as NASA plans on repurposing Viper's instruments and components for other lunar missions. However, this reflects NASA's long-standing mistakes in selecting contractors and managing projects. Both of these projects were highly anticipated and held great promise. Given that SLS is facing similar challenges, one question emerges to the forefront. Will it also be cancelled? The answer is a resounding yes. Within NASA's system, SLS is likely the most expensive project. Having started development in the early 2010s, the cost of SLS had reached $23.8 billion according to 2022 statistics. And it's likely even higher now. Specifically, developing the rocket cost $11.8 billion, with each launch potentially exceeding $2 billion, and each launch system and mobile launcher costing around $1 billion. In comparison, SpaceX's entire Starship system costs just $5 billion. Let me say that again, $5 billion. Incredible? Amazing? Unbelievable? Yeah, those are just some words to describe SpaceX's cost reduction strategy in the form of reusability. You might recall the GAO report from last year, which famously stated that senior NASA officials told GAO that at current cost levels, the SLS program is unaffordable. Compared to the aforementioned projects, SLS's problems are even more severe and concerning. Although it is intended for lunar exploration, its inefficiencies cannot be overlooked. If these issues persist, it seems likely that SLS could face cancellation. Of course, that will depend on NASA's decision, but right now, I still want to hear your opinion. Do you think the SLS should be cancelled? Let me know with a yes or a no in the comments section down below. Don't forget to leave a like, share the video, and subscribe to our channel to continue following SpaceX's development journey. In addition to cost issues, another factor that could lead to the potential cancellation of the SLS is the availability of alternative rockets ready to fulfill its role, particularly SpaceX's Starship. Beyond the cost advantages I mentioned, Starship outperforms the SLS in several ways. Although the official prototype is still in development, SpaceX has made significant progress with Starship HLS, or Human Landing System. This includes testing elevators and building and evaluating simulated airlock systems. Compared to the SLS, Starship holds significantly greater potential. While the SLS is primarily designed for lunar missions, Starship offers versatility for various applications, including Earth-to-Earth transportation and Mars colonization. In general, Starship's development potential far exceeds that of the SLS despite its lower cost. If NASA were to reallocate SLS's investment to Starship, they could develop a more cost-effective and capable vehicle for a wide range of future missions, not just lunar exploration. In terms of general progress, SpaceX has made impressive strides with Starship in just over a year. They've successfully conducted 4 missions, including the historic achievement of landing both stages of the rocket for the first time. Bear in mind that although the first 3 integrated flight tests resulted in RUDs, or rapid unscheduled disassembly, it doesn't take away the fact that the data gathered from each sequential mission were the building blocks to the Starship system's current iteration. Learning from your mistakes is definitely the fastest way to learn, and SpaceX does not shy away from failure. Given their track record, it's highly likely that SpaceX will accomplish even more in the coming years, surpassing what NASA could achieve with SLS within the same budget and timeframe. In short, NASA is grappling with significant issues stemming from their own missteps. It might be time for them to step back and allow more advanced vehicles and talented innovators like SpaceX's Starship to take the lead. This approach could pave the way for faster, cheaper, and more efficient space exploration. If you agree, hit that like button if you haven't already. Otherwise, folks, that's about it for today's episode. Thank you so much for tuning in, and as always, this has been Kevin from Great SpaceX. Until next time, keep looking up.